In the first part of this lesson, we worked a little bit with equations and some different ways to solve an equation. If we're going to continue to work with equations, though, which we are quite a lot this year, there are a couple of special situations that can happen when you try to solve an equation that you need to be aware of in case they come up, which they will. We're going to look at a couple of examples to show you what those situations are and what it looks like when you're trying to solve an equation that's doing one of those things so that you can recognize it in your work. So, here we go. A first example. Both of these are also going to involve a little bit of simplifying and using order of operations, so this is a good chance for us to review that and talk about that a little bit more. So this is an equation. It has one variable, but that variable shows up in more than one place. Yesterday we said when you're solving an equation, if you're not working with a replacement set and you're just on your own trying to figure out what the variable is, you should try to simplify the equation as much as possible. So that means you should try to use order of operations where you can. You should also try to combine like terms where you can. One important thing that you need to be aware of, though, that people get confused with is that each of these is a different expression. So we have one expression on this side, and we have a second expression on this side. Those are two separate expressions. When you're simplifying or putting pieces together, you have to work with those separately. I like to think of the equal sign as a wall. Things cannot pass through the wall. You can work on the left side of the wall, or you can work on the left side of the wall when you're putting things together. So we're going to see what we can do with both of these to clean these up a little bit. So on the left side of the equal sign, we have some parentheses, 12 plus 2. We can put those together and make that 14. Once we put those together, we don't need the parentheses anymore because we boiled that down to a single number. So we can just write that as 4n minus 14. Now we can look at the other side. Again, we have parentheses. 6 minus 2 is 4. And so now we have 4 times n. In algebra, another n times 4 or 4 times n. That's your commutative property. In algebra, we usually put the coefficient or the number first and the variable second. So even though this was originally had the n first and what will become the 4 second, we're going to switch that around. Also in algebra, we don't always write out the times symbol. We'll just put them next to each other, and that means multiply. 4 times n minus 9. Now, we are immediately going to run into a logic problem with this. Whatever I fill in for n, both sides of the equation are going to multiply it by 4. So no matter what I fill in for n, those two highlighted pieces will always give me the same number. So I'm going to be starting with the same number here and the same number here. Where I run into a problem is with what happens next. On one side, I'm subtracting 14, and on the other side, I'm subtracting 9. Well, if I'm starting with the same number, and on one side I subtract 14, and then I take that same number and on the other side I subtract 9, this will always give me two different answers no matter what I do. So that means no matter what I do, because I'm starting with the same number but I'm subtracting a different amount on each side, I will always get a false statement. I will always get two different numbers. And of course, two different numbers can't equal each other. I could never have 3 equal to 7. They're not the same. Or negative 4 equal to 6. They're not the same. So no matter what I do with this equation, I'm going to get a false statement. When that happens, and no matter what you do, you will always get a false statement, that means there is no number that I can replace n with that will make this equation work. Therefore, our final statement for our solution would be that there is no solution. So that's a special situation that can happen with equations, where you have two sides that can never equal each other, in which case we can never have a true statement and there's no solution. I told you there were a couple of special situations to watch out for. No solution is one. There's another thing that can sometimes happen when you're working with an equation as well. I'm going to give you another example to help show you what the other special situation is. Okay, here is another equation. Again, this is two separate expressions. My equal sign is like a wall. I can't travel through the wall, but there are things I can do to clean up the left side and then come over to the right side and also clean up the right side. On the left side, order of operations says to start inside the parentheses, and then within the parentheses I have division and addition. Division comes first according to order of operations, which means I would need to start with the 8 divided by 4 first. So if I do that, that's going to give me 5 plus 2 in parentheses plus 3k. And I haven't done anything over here yet. It's a good idea to rewrite what's on the other side just so you don't lose track of that other half. I can do one more thing on the left side. I can add the 5 and 2 together, and that gives me 7. And that's about all I can do on the left side because I don't have like terms, so I can't actually add those pieces together. So now I can turn my attention to the right side of the equation. Again, I'm going to rewrite this just so I don't lose track of it. Normally, order of operations would tell us to start in the parentheses. The problem is I can't add k in 32 because I don't know what k is. This is a great example of where we would want to use distributive property that we reviewed in the last lesson. Distributive property can let me put some things together without violating order of operations because distributive property gives me a way to rewrite this without parentheses. So if you have an opportunity to use distributive property to do that and be able to combine some things together, then you should. So distributive property says that everything in the parentheses I need 3 of, or in other words, I have to multiply by 3. So 3 times k, 3k. 3 times 32 is going to be 96. Here's where distributive property was helpful. Getting rid of the parentheses with distributive property created a situation where now I can combine my numbers without yanking anything out of parentheses and violating the order of operations. Some of you might be asking and thinking, well, wait a minute. When we did order of operations, you told us that addition and subtraction are on the same level and we work from left to right, so shouldn't we add first? One thing you have to remember in algebra was subtraction, and this is something, again, we'll talk more about because we're going to do some review with negatives. But I could come along and I could rewrite this as 96 plus negative 89, and it is the same thing. Now all I'm doing is adding, which means according to the associative property, it doesn't matter what order I add those 3 numbers, which is how I'm getting away with doing the 96 minus 89 and not the addition first. So if I go ahead and do 96 minus 89, that's going to give me 7. Now you should be noticing that these two sides are exactly the same. The 7 and a 3k are flipped around, but that's okay because commutative property says it doesn't matter what order I add. So 7 plus 3k is the same thing as 3k plus 7. If you are working with an equation and you end up with two sides like this that are exactly the same, then that means basically this equation is mirroring itself. Whatever I put in for k over here is going to give me an answer. But because the other side is exactly the same, if I fill that same number for k on the other side, it's going to give me the same answer. So no matter what I fill in for k, I'm always going to get the same answer on both sides, which means this equation will be true no matter what number I fill in. So I could fill in anything I want, and this one will always work. So since anything we want will always work, the way that we would word that is to say that the answer is all real numbers. We'll talk more about what a real number is in another lesson. But for now, real numbers are basically any number you can think of in math. Any whole number, any negative number, any fraction, any decimal, all numbers. You could put anything you want in there for k, and it will always give you the same answer on both sides. One last thing that we need to talk about to finish this lesson up, now that we've talked about special things that could happen with equations. The last thing we need to talk a little bit about is an equation with more than one variable. So far, we've been looking at equations that just have a single variable, but it is possible to have an equation with more than one variable. In this case, we're going to come up with an equation that represents a situation. I'm going to give you the equation, and then I will tell you what situation it goes with. So this is a situation about a gym membership. So the gym membership costs $16 per month. So that's where the 16 is. And then after you pay for your membership, you can also pay extra to participate in classes. So each class costs $2 each to participate in. So this particular person is wanting to participate in some Pilates classes at their gym, which is why we're using P for the variable, P for Pilates. So to get their total costs for the month, they would have to pay their $16 fee, and then they would have to pay $2 for each of their classes, which is why we're multiplying by how many classes they're taking. And that adds up to the total cost. So in this case, we have two variables or two moving pieces. The number of Pilates classes this person is taking, which is going to impact their total cost. We need to use a variable for the cost because the cost changes based off of the number of classes the person takes. When you have a two-variable equation like this, in order to solve the equation, you usually need to be given information about one of the two variables. So right now, we can't solve this equation the way that we were solving equations earlier in the lesson because we have two things we don't know. We would need more information to solve a two-variable equation. So we're going to add some more information into this. So let's say over the course of a month, we took 12 Pilates classes. Now we have a piece of information. So we can take that information and we can drop it in where it goes. So P is the number of classes we took. So we can take our equation and we can fill in the information we were just given. Now, this is still an equation that needs to be solved because we still have a missing piece of information over here, the cost. But now that we know how many Pilates classes we've taken, we can go ahead and track through this equation and figure out the cost, just like we were doing with some earlier equations. So we would use order of operations. 2 times 12 is 24. 24 plus 16 is 40. So that means our total cost for the month is $40. So we started out with 2 variables, but as soon as we added in a piece of information, we could solve the equation from there. So it is possible to solve or to work with 2 variable equations, but generally you need to be given information about one of the 2 variables, and then you can go from there.